This is Sukruti Joshi. Our today's topic for this video session is different types of electrodes. Here, in this particular session, we will divide our electrodes in different parts. So the first part that we will have here is reference electrodes, which is standard hydrogen electrode, which is also known as SHE. Then we will have calomel electrode. Next one that is available is AgCl2 electrode. We have here glass electrode. So these types of electrodes are basically known as reference electrodes. Reference electrodes are basically the electrodes which we can use for our reference purpose. We can find out the electrochemical cell's potential with reference to this kind of electrodes. Okay? Here, first one is indicator electrodes. Now, the first type that we have seen is reference electrode. Second one is known as indicator electrodes. Indicator electrodes actually indicates each and everything or electrochemical potential by itself. So reference electrode will be used for reference purpose, while the indicator electrode will be used for indication purpose. Now let's see that which types of electrodes are actually here will be taken as indicator electrodes. So number one is acid-base electrode. Number two is redox electrode. Number three is precipitate electrode. Now, let's take a look on each and every type of electrode one by one. So first of all, as we have seen, the first type of electrode that we will take into account is reference electrode. Okay, so the first reference electrode that we will take into detail is standard hydrogen electrode. Standard hydrogen electrode is also known as SHE. Now here in the image, as you can see, that shows you the working or the actual structure of SHE. Now as you can see in the image, we have here PT electrode, that is platinum electrode covered with H2 gas, which is covered or totally dipped by or in a glass hood. Now that whole structure contains positive charge that is available from the wire. Okay, so that will give you positive charge that behaves as a cathode here. Now that particular glass hood structure will be dipped in one molecular solution of H plus ions at 25 degrees Celsius. Right? Now how this platinum electrode is surrounded by the H2 gas. So as you can see in the image, we have here H2 gas, or the input of H2 gas is given at 1 atm pressure. So as you can see it in the image, we have that particular structure. The upper part is basically the wire. Okay, now that gives you a charge. There's another one that is an input of hydrogen gas, which is an input of hydrogen gas at 1 atm pressure. Okay, now that way or that particular hydrogen gas will go to the platinum electrode or platinum plate, which is at the bottom of the glass hood. Right, now whole this structure will be dipped in 1 molar solution of H plus ions at 25 degrees Celsius. Okay, so the standard hydrogen half cell or standard hydrogen electrode, which is also known as SHE, is selected for coupling with the unknown half cell. As I said you earlier also, this is a type of reference electrode so that you can calculate another half cell's potential with reference to this particular electrode. Okay, so that is how it works. It It consists of platinum electrode which is immersed in a 1 molar solution of H plus ions maintained at 25 degrees Celsius. Hydrogen gas at 1 atmosphere enters the glass wool and bubbles over the platinum electrode. Okay, so in general condition, in this manner the platinum electrode will be in contact with the H2 bubbles or H2 gas. Okay, now the hydrogen gas at the platinum electrode passes into the solution, forming H plus ions and electrons. So let's see that which equation actually occurs or which reaction actually occurs at that particular point. Okay, so H2 gives 2H plus plus 2 electron. So this particular reaction occurs at that particular point, which is your platinum electrode surrounded with H2 gas. So this type of reaction occurs there. So there what happens, 2 electrons are released and 2 hydrogen plus ions are formed. Okay. Now let's see the EMF. What is the value of EMF? So the EMF of standard hydrogen electrode is arbitrarily assigned the value of 0 volts. So She or SHE can be used as a standard for other electrodes. Okay, understood it very clearly. Here the value of or the EMF of this particular electrode will be taken as 0. So what you need to do is it will work as a best reference electrode for any type of other half cell. Okay. Now the half cell whose potential is desired is combined with hydrogen electrode and the EMF of the complete cell determined with the voltmeter. Now here the EMF of the cell is the EMF of the half cell. So what we will get here is E0 cell is equal to E0R minus E0L. So if we take it here on the left side, our half cell whose potential will be determined has to be taken on the left side. So what we have to do here is we will put our SHE on the right side. So 0 minus 0.76 is equal to minus 0.76 volts. So that is the EMF or the half cell potential of that particular half cell. Okay. For an example, it is desired to determine the EMF of the zinc electrode. So zinc oblique zinc plus 2, and that particular half cell is connected with the SHE. Okay, so how we can write that particular one? So zinc, this is an electrochemical cell's representation. Okay, understood it very clearly everyone. Zinc oblique zinc plus 2. So zinc is in connection with zinc plus 2. We have put the symbol of salt bridge there. So put the salt bridge over it. H plus in contact with H2 gas, that is at 1 atm pressure, and platinum electrode. So it is basically the concentration that zinc and zinc plus 2, that particular compartment is in contact with our SHE. So right side has SHE, left side has the half cell whose potential has to be determined. Now the EMF of the half cell has been found to be minus 0.76 volts. So which is the EMF of the zinc half cell. Similarly, the EMF of the copper electrode, which is Cu plus 2 oblique Cu, can be determined by pairing it with SHE. So when the electrochemical cell can be represented as platinum with H2 gas at 1 atm pressure with contact with H plus. Salt bridge symbol has to be there, and it is in contact with Cu plus 2, that is in contact with Cu solid. So in this manner, as you can see, here we have put that on the left side, and our Cu half cell or Cu plus 2 and Cu half cell is on right side. So the EMF of this cell has been determined to be 0.34 volts, which is the EMF of copper half cell. So E0 cell is equal to E0 R minus E0 L. So 0.34 minus 0, and it will give you 0.34 volts. Okay. So when it is placed on the right hand side of the zinc electrode, the hydrogen electrode reaction is 2H plus 2 electron gives H2. The electrons flow to the SHE and it acts as the cathode. So when the She is placed on left hand side, the electrode reaction is H2 gives 2H plus 2 electrons. Now the electrons flow to the copper electrode and the hydrogen electrode as the anode. So evidently the SHE can act both as anode and as cathode, and therefore can be used to determine the EMF of any other half cell electrode or single electrode. Now the SHE, which is the standard hydrogen electrode, is not the most convenient standard electron to use in the laboratory. The gas has to be carefully controlled, and hydrogen gas can form explosive mixtures with air. So we can't use it all the time or every time in the air. So any other system whose potential has been determined relative to SHE can also be used as secondary standard electrode. Now our next electrode is the calomel electrode. So it is the most commonly used secondary standard reference electrode. The standard calomel electrode, which is also known as SCE, consists of wide glass tube with narrow side tubes. It is set up as illustrated in figure. That means a platinum wire will be dipped into liquid mercury covered with solid mercurous chloride Hg2Cl2, which is also known as calomel. Now the tube is filled with 1 molar solution of KCl or saturated KCl solution. Now the side tube containing KCl solution provides the salt bridge which connects the electrode to any other electrode. Okay, in this manner how it works. So this is the structure that how SCE will work. So as you can see in the image, what we will have is mercury is in contact with mercury solid calomel. That solid calomel is in contact with saturated KCl solution. All the 3 compartments or all the 3 components are in contact with platinum wire, and that particular SCE is in connection with salt bridge. So that salt bridge will connect it to other half compartment or other half cell. So the calomel electrode is represented as Cl minus, which is 1 molar solution in contact with Hg2Cl2 in contact with Hg, and the half cell reaction can be written as Hg2Cl2 plus 2 electrons gives 2Hg plus 2Cl minus. Right? Now as you can see in the image, we have put all both of the electrodes together. So platinum in contact, or platinum and H2 gas in contact with H plus, in connection with salt bridge, in connection with KCl, that is 1 molar, in connection with Hg2Cl2 and Hg, right? So at 25 degrees Celsius, that is the particular cell potential, right? The EMF of the given cell is plus 0.280 volts. That is the calomel electrode EMF with respect to standard hydrogen electrode, which is plus 0.280 volts. So this means that 0.280 must be added to any electrode potential measured against a calomel electrode, and this would give the standard potential on the standard hydrogen cell. Now second one is the dipping calomel electrode. Right. So in dipping calomel electrode, what we will have is we have sintered glass disc at the bottom in connection with saturated KCl, in connection with porous plug that is in contact with Hg2Cl2, and then we have Hg. So all these compartments are actually in connection with platinum wire. Right. So for many purpose, a calomel electrode is manufactured as a self-contained unit, and it is used by simply dipping the tip of the electrode in the solution of another electrode whose EMF is to be determined here. This type of electrode is often referred as dipping calomel electrode. So here the mercury and calomel are held in narrow central tube by a porous cotton wool plug, and the platinum wire dips into the mercury. Now, the KCl saturated solution contained in the electrode makes contact with the other electrode solution through sintered glass disc. This disc functions as salt bridge between the two solutions. Thus, a galvanic cell is set up and the EMF is measured with the help of voltmeter. Right? Now our next one is standard silver-silver electrode. So as you can see it here, this is the structure which is shown in the image. Okay, left side we have our standard hydrogen electrode, right side as you can see, Cl solution, which is 1 molar solution of Cl, is in contact with silver electrode which is covered with silver chloride, right? So that behaves as cathode and directly in connection with SHE. Right? So in this electrode system, the silver wire or silver strip is covered with silver chloride, which is highly insoluble substance. It is dipped in potassium chloride solution in which the concentration of Cl minus ion is 1 molar, and this electrode can be represented as Ag in contact with AgCl in contact with Cl minus, which is 1 molar solution of Cl. The half cell reaction of Ag-AgCl electrode is AgCl accepts the electrons, gives Ag plus Cl minus. Our next one or next type of electrode here will be the glass electrode. Okay, so a commonly used secondary standard electrode is so-called glass electrode, and its EMF can be determined by coupling it with SCE. Now the glass electrode provides one of the easiest methods for measuring the pH of given solution. So as you can see in the image, we have a thin walled glass tube, and in that AgCl solution is there in contact with Ag wire in contact with 1 molar Cl. Okay, so that whole structure contains these things. Now a simple type of glass electrode generally consists of a glass tube having a thin walled bulb at the lower end. The bulb contains a 1 molar HCl solution which is sealed into the glass tube and is a silver wire coated with silver chloride at or with lower end. So it can be represented as Ag, AgCl in contact with 1 molar HCl in contact with H plus, which is taste solution. So when it is placed in a solution, the potential of glass electrode depends on the H plus ion concentration of the solution, and the potential develops across the glass membrane as a result of concentration difference of H plus ions on the two sides of the membrane. This happens much in the same way as the EMF of concentration cell develops, and the potential it is determined against SCE. Okay, so in this manner we can use electrodes to determine the half cell potentials. This is all for this session. Next we will see in our next sessions. Thank you so much everyone.